Okay, today we're going to do a bench test on a fuel pump relay. This will work for any automotive relay, honestly, as long as the voltage is 12 volts, which every one I've ever seen is. This comes off my dad's old Ford. He says he's having intermittent issues with the fuel priming when he turns the key on. Sometimes it will not turn on, or it will not prime immediately when the key switch, and he has to flip it 3 or 4 times to get it to go. So immediately, I'm going to assume that's an electrical issue. Typically your motor's either good or it's bad on the fuel pump. So we're going to be looking at switches. We're testing different components. I've already tested the ignition relay, and that all seems good. So after that, we have two more electrical components on this. We have the fuel pump relay, which is usually the culprit. And then under the dash, there's also, Ford puts in a inertia switch, fuel cutoff switch. So I believe that's if you get in an accident, it shuts off the fuel pump to stop any further types of dangers. So we're going to start with the fuel pump relay, and I'm just going to show you how to quickly bench test it. To do that, I like to use, you can use the car battery itself, but I just use my little 12 volt Milwaukee batteries, and I have a little battery adapter with outputs, and this one has a switch on it. I got that $12 off of Amazon, and it's perfect for little applications like this. And you're going to use a multimeter that reads resistance or continuity, so you can get a measurement off of that. Typically, it's going to be hard to see with the camera, but there are diagrams on the sides of these relays, and on the top you'll see the numbers of the pins. So what I've done is I've actually drawn it out here, so we know what we're looking for. And this is going to be a 12 volt 30 amp relay. It's got one normally open and one normally closed contact. In the vehicle diagram, that normally closed contact is not used for anything, but we'll still measure it to see how it's going to play out. So 85 and 86 is going to be our coil. So that's where we're going to apply our 12 volts to get the switch and read our continuity. So we'll take continuity measurements from pin 30 to 87A. Then we'll apply power and take it from 30 to 87 and to see what our resistance is between those. And that's the way that the pins line out on the relay. Between 85 and 86, we'll take a coil resistance just to make sure the coil's good. And you can find that in any of the workshop manuals, or like I have here, I have two of the identical part numbers. So I should be able to check the suspect relay against a different relay and see if those are equal. If they're pretty close to equal, we'll call them good. If they're outside of 10-15% difference, then it would be time to replace the relay. So we'll be looking at coil resistance on each one. Then we'll take measurements from points 30 to 87A with no voltage. There should be continuity. Then we'll go 30 to 87. There should be no continuity with no voltage applied. And then we'll apply the voltage, go from 37 to 87A. There should be no continuity. And then we should have continuity from 30 to 87. So the first part of this step, always, when you're troubleshooting, one particular easy method to save you a lot of time is going to be testing your instrument to make sure it works before you start. Somewhere down the line, that's going to save you a lot of time. Sometimes the leads will be bad and you'll be chasing your tail because you never checked it. It's happened to me, it's happened to a lot of people. But we're going to start by taking this relay. This should be the good relay, the known good relay. And we'll take a look from 30, which is this pole here. We'll go to 87A. And we should have continuity. 87A is the middle one. Not bad. Okay, so now we should have continuity. And we're good there. And we've got no continuity at 87. So now I'm going to apply 12 volts to this, and the switches should change. Do that. Go to 85 and 86 on the sides. And this is just a coil so you don't need to worry about polarity. It'll work in either direction. And when we turn the battery switch on, you'll hear a click. That should have changed the state. So our resistance from 30 to 87, it should be open. 87A. That's good, and we'll go to 87. And we've got a good reading. We got 0 ohms. It's exactly what we would expect. So we're going to do the same test to this one. I'm going to shut off the power and we'll test the coil resistance as well. Probably would have been easier in a vise or something. Okay, test the coil resistance real quick. 85 and 86. .1. Okay. Then we'll test the suspect relay real quick. Hook him up. So 87A, we should have continuity. That's going to be the middle pin. We're good there. 87, we should have no continuity on the outside. We're good there. We'll apply some voltage to it. And turn on our little battery switch. We'll go back to 87A. I should have no continuity. We're good there. Then we'll go to the outside, which is 87, and I should have continuity here. We got continuity. So that's checking well. Oh, nope. See any type of jumping like that, that's a suspect relay. That can cause an intermittent issue. Yeah, I'm going to replace that relay. I don't like that at all. Do not like that at all. That's exactly what we're looking for.